Welcome all. In this session we will discuss linear magnification on reflection of the light. What is mean by linear magnification? How to take linear magnification for real image, for virtual image, and for concave mirror how to take linear magnification, and for convex mirror how to take linear magnification, that we will study in detail. See here. Let us discuss concept of linear magnification. To understand this concept of linear magnification, let us take a concave mirror. Look at me. How to take concave mirror? I can take, this is one concave mirror. One concave mirror, say one part is silvered, bulging part is silvered and depressed part is reflecting one. Right around this. Now shall I take, this is nothing but principal axis of the given mirror. Right around, we are calling this is pole. What we are calling this is pole. Center part of the mirror we are calling pole. Now in front of mirror, let us consider an object of somewhat height. See here, shall I take, this is one object. Say let us take this object is equal to AB. AB represent height of the object. This height of the object can be represented by O. Are you following? Now from this object let us consider the ray of light incident at pole. Incident at pole. How it is? Look at me. From this object let us consider the ray of light incident at pole in this direction and get reflected. How it get reflected? After incident, let us consider this ray of light reflected in this direction. Are you following me? Now let us consider one more ray of light that is passes through center of curvature. Already we know that. See here, let us consider one more ray of light. How it is? I'll extend this mirror like this. How it is? Let us consider one more ray of light incident like this incident, and get incident. After incident, let us consider this ray of light retraces its path. In what direction it comes, in the direction it goes. Right. After reflection, where the ray of light is meeting? After reflection, all the rays of light meeting at this point. At what point? At the A dash point. Then I can call this point is nothing but center of curvature. Somewhere here focus is available. This I can call focus. Right? Remember. Now all the ray of light meeting at this point A dash. Then how to take the image? If I draw this line, this line indicates A dash B dash, that represent image of the object OB. How it is? This image is appeared here. At what point it is appeared? It is appeared at A dash and B dash. We know that AB represents size of the object, then A dash B dash represents size of the image. This we are calling size of the image. Question is how to define linear magnification. Linear magnification is a ratio of size of the image to size of the object. Where it is? This I can call size of the image, and this we are calling size of the object. How to define linear magnification? See here. Linear magnification simply I can define size of image or height of image. Size of image or height of image divided by size of object. Size of object. Right. What is size of image? Size of image can be represented by I, size of object can be represented by O. Then how to define linear magnification? Linear magnification is equal to what value? I divided by O. This is general condition. Simply how to define linear magnification. This linear magnification, it has no unit. Because size of image measured in centimeter or meter, size of object also measured in centimeter or meter, that SI unit get cancel or CGS unit get cancel, so that this linear magnification only has the value. Then this linear magnification either it is positive or negative. For both mirror we will see either it is a negative value or it is positive value for concave mirror, and for convex mirror it is always positive. Look at my students here. Thing is, if the case size of the image is equal to size of the object, I is equal to O. If I is equal to O directly, M is equal to 1 value. linear magnification is one value. When linear magnification is one value, if size of the image is equal to size of the object, then linear magnification is one value. First thing, but I said that linear magnification either it is positive or negative depending on nature of the image. Depending on nature of the image, this linear magnification is either positive or negative. How it is positive initially for concave mirror, that we'll see. How it is negative later we'll go for convex mirror. Look at here. Now how linear magnification is negative, that we'll see now in detail. Look at me. Shall I take here? Here I will choose. How linear magnification is what value negative? Generally linear magnification for concave mirror is negative for real and inverted image. For real and inverted image. See here. For real image, linear magnification for real image. Linear magnification for real image. For real image. That we'll see now. How it is positive, how it is negative. Generally, for real image, for concave mirror, linear magnification is negative. How it is negative, that we'll see now. Look at me. Again, you will take, this is mirror, concave mirror I will take, choose. Right. This part we are calling silvered. Right around this. Now I can call this is principal axis of the given mirror. I can call this is pole. Right. This part, center part, I can call this is pole. Right around. Now let us consider an object situated behind the center of curvature. Consider this is the object situated here. This object I can call AB. AB is nothing but object and its height can be represented by O. Right. Now a ray of light incident at pole and get reflected back. How it is? Look at me. This is the ray of light incident at pole I will take. Look at me. This ray of light incident at pole. At this point it incident. Right. How it get reflected? After incident the ray of light must be reflected in this direction. In this direction. Now one more ray of light that is passes through center of curvature. Center of curvature means how it is? Look at me. This is nothing but object. From this object let us consider the ray of light which is passing through center of curvature. Incident here. After incident, how it goes? It get reflected back. I mean, it retraces its path. Similar to this one. After reflection, where the ray of light is meeting, at this point, ray of light is meeting. So it is nothing but center of curvature. C point. How to take the image? If I draw a straight line. So this indicates what? Image. Where the image is there, image appeared in front of the mirror. Then I can call A dash, B dash is nothing but image, and its size can be represented by I value. Very simple. Right around this. Then generally sign convention. Come to sign convention in optic. Distance measured upward perpendicular to principal axis taken to be positive. Distance measured downward perpendicular to principal axis taken to be negative. Generally, what is linear magnification? Size of the image to size of the object. Size of the image divided by size of the object. Look at me. Size of the image, distance measured downward perpendicular to principal axis taken to be negative. Distance measured upward perpendicular to principal axis, that is taken to be positive. Right around negative positive, then what is linear magnification value? From this linear magnification is equal to what value? I divided minus I divided by O. Linear magnification is negative. Then this linear magnification general formula we have to put. What is value? What is general formula for linear magnification? Simply, for real image, linear magnification is always negative. Negative means actually size of image must be smaller, size of objects must be bigger. If this is smaller, this is bigger, then value must be less than 1. I mean, your linear magnification is less than 1. Less than 1. For what? For real and inverted image. For real and inverted image, linear magnification is what value? Less than 1 value. Then I need general formula for linear magnification. That also negative here. How it is? Look at me in this diagram. ABC looks like one triangle. Which is triangle? triangle ABC looks like one triangle. One more triangle A dash B dash C looks like another triangle. A dash B dash C looks like another triangle. Both are similar. These triangles both are similar. Right or wrong? Both triangles are similar. Then from similar triangle, ratio of height to base are equal. Ratio of height means that is AB divided by what value? A dash B dash. Ratio of height of the triangle divided by base of the triangle, which is base. Base can be represented by what value? BC. BC divided by what value? B dash C. Right? B dash C value. I can take one more triangle. Look at me here. I need image only. See here. Shall I call it as equation number 1 now? 1 now. Right? Or else you can go in alternating manner. Other than this. See here. One more triangle is there. ABP looks like one triangle. Other than this, shall I go one more triangle? Look at me. ABP looks like one triangle. ABP. Other than this. Shall I take here? ABP looks like one triangle. Triangle ABP looks like one triangle. One more triangle. Triangle A dash B dash P looks like another triangle. ABP A dash B dash P. ABP and A dash B dash P. Look at me here. A dash B dash P are similar triangles. Are similar triangles. Right? I can take ratio of size to height. Look at me here. I can take ratio of size mean AB divided by A dash B dash equal to how much it is? So I can take PB divided by PB dash. PB divided by PB divided by PB dash. Both are similar triangle. According to sign convention. See here. Look at me. According to sign convention. AB this one. AB mean how much? Distance measured upward perpendicular to principal axis taken to be positive. So AB is equal to what value? O taken as positive. A dash B dash I downward distance taken to be negative. Shall I take it is what value? Minus I. Are you following this? PB is equal to what value? Distance between pole to object is called as object distance. So opposite to direction of incident ray, that is taken to be negative. PB dash image distance V value. V also negative. How to take it is minus value. Right around this. So minus get cancelled. Shall I take one more way? I divided by minus I divided by I. O divided by I is equal to what value? U divided by V. Make it reverse. Reverse mean how it is? I divided by O is equal to what value? V divided by U minus here. Right around. Then see here, or else I divided by O is equal to minus V divided by U. Right? I divided by O is equal to linear magnification. What is linear magnification? Minus V divided by U. It is general formula. But how to decide linear magnification is positive and negative? Linear magnification can decide either object distance and image distance both are in upward direction taken to be positive. But here, look at me here. Object size is in upward direction, that is positive. Image size is in downward direction, that is taken to be negative. So that for real image, how to take linear magnification, it is negative value. And what it is? General formula for linear magnification. Don't confuse. This is general formula for linear magnification, and what it is? Linear magnification for real image. For concave mirror, this linear magnification is negative. Similarly, it also positive, depending on nature of the image. How it is? Now object is placing just behind the center of curvature. Now I would like to put the object is placed between pole and principal focus. That we'll see how it is. Look at me. How to place? How linear magnification is negative, that we'll see now. See here. Look at me. Linear magnification for virtual image. For virtual image I will see. For virtual image. For virtual image we will see how linear magnification is negative. Look at me here. Simple I can take again, it is concave mirror, convex concave mirror I will take. Let us take, this is concave mirror, right or wrong? I can call this is principal axis. Simply I can call this is principal axis. Are you following me? Now let us consider object is placed between pole and principal focus. How it is? Now I would like to put this is nothing but object. Say this object is equal to my, this object is equal to AB. AB is the object, right? This I can call pole. This I can call pole, right? Now consider the ray of light incident. How it is incident? Let us take the ray of light is incident from the object, incident at this point. After incident, how it get reflected? Now it get reflected in this direction. Let us take this point I can call focus, right around this, right? Now consider one more ray of light. How it is comes? One more ray of light incident at pole, incident at pole. After incident, how this ray of light is reflected? This ray of light is reflected back in this direction. Are you following? How it is? One ray of light incident at M point. Look at me. One ray of light incident at M point get reflected passing through focus. Second ray of light incident at pole and get reflected. But here all they are reflected in backward direction. How to take the image here? If the reflected ray, this is the reflected ray. If the reflected ray produced in backward side, or this reflected ray produced in backward side, where they meets, they can meet at some other point, say A dash, right? Then if we join this A dash, this one A dash and B dash, that represents size of the image. AB represents size of the object. A dash B dash represents size of the image. We know linear magnification formula. How to take? Linear magnification is what? Size of image divided by size of object. How it is positive here? Look at me. Size of image in upward direction, that is taken to be positive. Size of object also taken in upward direction, taken to be positive. So in this case, what is linear magnification? Linear magnification is positive. Then what you got? What you got directly? For virtual image, always linear magnification must be greater than 1. Greater than 1 and positive. How it is? This image size is bigger, size of object is smaller. Size of object is smaller and size of image is bigger. So that here what you can taking? Size of image is greater than size of object, so that this linear magnification is always greater than 1. Right? So for virtual image, always linear magnification is what value? Positive value. And for real image, linear magnification is what value? Less than 1 value, and it is negative. And it is what value? General formula for linear magnification. Simply you got M is equal to minus V by U. Minus V by U. Remember this point. Look at me. Then for convex mirror, again how to take? We know that wherever image is virtual, their linear magnification always positive. Remember this point. Because here this image appeared behind the mirror. This we are calling virtual image. Then similarly for convex mirror, how to take? For convex mirror, how it is possible, that we'll see. Look at me. One more case we'll see how linear magnification must be negative for convex mirror. Look at me here. This linear magnification for convex mirror, how it is positive? Because for convex mirror, always image is appeared as a virtual. Look at me. I can take it is nothing but convex mirror. So this part I can call silvered part. Here silvered part is diffraction one and reflecting part is bulging. Now this I can call principal axis. What are calling this we can call pole. Let us take. This is principal axis, just I want to extend it. Right. Now object situated somewhere where it is, look at here. Let us take this is nothing but object. This object situated here. So I can call this nothing but AB object. This AB object has somewhat height. Height can represent by O value. Right. Now consider the ray of light incident at pole and reflected. How this is? This is the ray of light incident at pole. After incident, the ray of light must be reflected back. How it in direction? In this direction it reflected. Right or wrong? In this direction ray of light incident and it is reflected light. Right. One more ray of light, how it is? Let us take one more ray of light incident at this point and it retraces its path. Or it can take like this also. After incident, how it get reflected? Now it can get reflected like this. Like this it can get reflected. This is one reflected ray, this is second reflected ray. If I extend this reflected ray in backward side or this reflected ray in backward side, are you following this? Where they can meet at some other point, say A dash. Then if I join this, this represent what? This represent A dash, B dash, that represents size of the image. How it is? This I can call size of the image. It is very smaller, very smaller. And what about the size of the object? It is nothing but very bigger. Then how to define linear magnification in this case? Linear magnification is equal to size of image divided by size of object generally. But size of image in upward direction taken to be positive, size of object also upward direction, that also taken to be positive. Then what is linear magnification in this case? Linear magnification simply it is taken to be positive. So wherever image is virtual mean image appeared at behind. Right. But this linear magnification in terms of U, V and F. In terms of U, V and F, how to take? Before that, we know linear magnification. How it is? Either you can represent by what value? I divided by O is equal to minus V divided by U. Generally, we got this formula. Because separately shall I take one more way? See here. M is equal to minus V divided by U. Minus V divided by U. Generally this formula, or you can take this formula. Right. In terms of U and V, linear magnification in terms of U and V, how to take? U, V and F. See here. Linear magnification in terms of U and V. In terms of U, V and F. U, V and F. In terms of U, V and F. How to take linear magnification? To understand this, now we know lens formula. Mirror, not lens formula, we know mirror formula. What is the relation between object distance, image distance and focal length? That we are calling what? Mirror formula. What is the relation here? Simply I can take 1 by U plus 1 by V is equal to how much? 1 divided by F. Let us call it is equation number 1. Right above. Then divide this equation on both sides by U. How to take? U divided by U plus U divided by F is equal to U divided by F. Simply I multiply U. Then U by U get cancelled, remaining 1 plus U divided by V is equal to U divided by F. Right? Or else U divided by V is equal to U divided by F minus 1. Or again U divided by V is equal to U minus F divided by what value? F. Or else make it reverse. Reverse mean V divided by U is equal to F divided by U minus F. Remember this point. But we got this formula. M is equal to minus V by U. Linear magnification is what? Linear magnification is equal to minus V divided by U. But we got V by U is equal to this value. Then how to put this formula? Linear magnification M is equal to minus of V by U is equal to how much? F divided by how much? U minus F. Or in terms of positive value, how to take linear magnification? F divided by how much? F minus U. This is linear magnification in terms of object distance. In terms of object distance. Similarly, this linear magnification in terms of image distance also you can see. In terms of image distance. See here. Image distance mean you can take one more way shall I take? Again this is the this is the mirror formula. 1 by U plus 1 by V is equal to 1 divided by F. Now in this case I divide U on both sides, multiply U on both sides. What I will do now? Just I want to multiply phi on both sides. Phi mean simply I can take V divided by U plus V divided by V is equal to V divided by F. V by V is equal to what value? Let it this value is equal to this one plus 1 is equal to V divided by F. Or else how to put this value? V divided by U is equal to, how to take? V divided by F minus 1, or V divided by U is equal to what value? V minus F divided by how much? F value. Let it be this formula. But again linear magnification, M is equal to what value? Minus V by U again, like this. Linear magnification how much? Minus V divided by U. V by V got already. Then how to put this? Minus of how much? V minus F divided by how much? F value. Or else in terms of positive value, how to take? F minus V divided by how much? F value. This is linear magnification. Linear magnification in terms of image distance I take. In terms of image distance this is formula. In terms of object distance this is formula. Right? This is linear magnification. But this concave mirror and convex mirror had lot of uses. Concave mirror and convex mirror, they used for lot of commercial purpose. We know that for concave mirror either real image can appear and virtual image can appear. But for convex mirror, remember always virtual images appear. For nature of the image, this both mirror had lot of uses. Concave mirror are used by dentist, ENT specialist to focus the ray of light on ear's nose, teeth, to examine the organs of the human body. I mean to examine ear, to examine teeth, to examine the nose. Using concave mirror, we are incident the ray of light on the organs to examine the further study. Similarly, this concave mirror can used preferred over a plain mirror. I mean it is used as a shaving mirror and makeup mirror. But the main use of the concave mirror is used as a shaving mirror. I mean used as a makeup. So that this concave mirror also called as convergent mirror, also called as makeup shaving mirror. And for reflectors to reflecting street lights, concave mirror can be used for various purposes. Similarly, look at the convex mirror. This convex mirror can produce very smaller image. Due to smaller image, it cover large amount of area. Due to large amount of area, this convex mirror are used as a driver mirror. Used as a driver mirror to view the background of vehicles. I mean, it produces very smaller image and covered the bigger area. For this purpose, we are using the convex mirror as a driver mirror. If concave mirror used in headlights, torches, street lights, for that purpose we are using concave mirror. But main use of the convex mirror is it is used as a driver mirror because of reason only it produces very smaller image which cover bigger area. I mean it is used as a rarer image for drivers. And in bigger shops to monitor activities of the customer, convex mirror can be used because convex mirror can produce very smaller image and it cover bigger area. To cover bigger area, we are using the convex mirror in big shops to monitor the activities of the customers. So these are main uses of concave mirror and convex mirror. So up to here reflection of light has been over. Remaining numerical we will see in the next session. Thank you.